for 4.5. Can you focus? There you go. No more advice. Good. Okay. Find the speed of the tile when you hit the ground. The answer for this one, I believe, is 16.3. Anyone didn't get 16.3? They get 16.3. Find the speed of the tile when you hit the ground. Okay. So if I want speed, obviously my focus will be kinetic energy. Correct? Okay, so you have KE at bottom will be equal to what? Sorry? You will consist of your GPE at the edge of the roof, and you will also account for the KE that you have at the edge of the roof. Right? Now there's no friction anymore, the feather falling through the air anymore. Correct? Okay, so this is just going to drop like this. Okay, what's the velocity here? Okay, so you have this additional mgh to account for. Now, okay, Olivia, walk me through it. So you have half times 0.3 times v squared. What's your GPE?
0.3 times 10 times 12.3.
Okay. What's your KE?
Half times 0.3 times 4.5 squared.
Good. Okay, from here, then you calculate. And you get your new answer. Those who got it wrong, or those who don't have your worksheet, that's what you are. You got it correct?
16.6.
How do you get 16.6?
Carry on.
You will have ECM, yes.
But that's not what you say.
Can?
Just put most.
Can you okay? Okay, yeah?
I don't have to know.
Okay, first. Okay, explain how thermal energy is removed quickly by the features of the tube. You need to keep this fella cool. This guy needs to be cool. Okay, Shafiq, how? How will you keep him cool? How will you keep him cool? 3 marks. That's 3 points.
Copper.
Copper.
You make it black.
Black.
Fins.
Fins. Okay. Explain. Okay, the copper. Why is copper? What does copper help? Okay, so copper is a good conductor of heat. Conductor of heat. So what?
You dissipate the heat.
Can I would say absorb or okay, actually dissipate is a pretty good word. Okay, dissipate heat away from your target. What about your fins? What do the fins do?
Increase the surface area.
Okay, fins increase surface area. And oops. So what? So if I increase surface area, So yes, your fins increase your surface area. Now we're done. Okay, hence, okay, if fins increase your surface area, hence allowing a higher, higher rate of conduction away from the target. Shafiq, last one. What does the black do?
So ideal color for radiation. So you really the heat wave from
Okay, black surface is a good emitter of radiation. Hence, okay, of course, you will radiate the heat away from your target. Hence, keeping target. When moving through a strong magnetic field, path taken by a beam of electrons changes but your X-ray remains on its original path. Why? Anybody think? But if you have strong ionizing power, does that help you with the magnetic field? Magnetic field, so far, when we learn about deflections in a magnetic field, it's either you have a compass or you have a charged particle, right? Because then you use this now. Now here's not about a compass, which means we have to be talking about the fact that your X-rays have no charge. So Fleming's left-hand rule doesn't apply to it because there's no charge. That's why he doesn't deflect. Okay, one possible effect, okay, you can say cell mutation. Okay, you can talk about your cancer and whatever shit. Blah 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 blah. Or it's like a relationship. Okay, good. Question 19. Watch company test the new design. Define pressure, force per unit area. Okay, this one is nothing. For a range of depths shown, state a similarity in the pressure exerted by pure and seawater. Nero? What is the similarity? Increases as depth increases. Good. Okay, increases as depth increases. What's the difference, General? Seawater, okay, the increase in pressure by seawater is higher. But okay, determine density at depth of 2000 meters. You have rho times g times h equals to 20.7 times 10 power 6. I believe the answer is 1035. Okay, if you guys have the sheet that I sent, the answer sheet that I sent out, okay, and apparently I sent it to some people only, I'm sorry. Okay, but the answer sheet includes your atmospheric pressure here. Okay, I'm sorry, there is a change to the answer because this one is pressure exerted by seawater, not atmosphere. Atmospheric pressure is not included, that's why this one is 0. So we also do that asking. Okay, good. Okay, so we don't have this one. Is divided by 10 times 2000. What the hell? Okay. Yeah. Okay, go and do a calculation. I believe it's 1035. Correct me if I'm wrong, okay? kg per meter cube. Are we okay for part C, guys? Okay, good. Part D. The watch has a surface area of 2 times 10 power negative 3 meters squared. Withstand a maximum force of 85,000 newtons. So whether it can be submerged, of course, okay, I'm not sure if you guys did this, but those of you that tried it, the answer is yes. Okay, it can be submerged. There's two ways to do it. Number one, you tell me that the pressure that it exerts, you tell me that the force it exerts is less than 85,000. The other way is, okay, if you are going to use your 85,000, okay, so let's say the first one, method number one is force exerted at 4,000 meters equals to your pressure at 4,000 meters, 41,500, 41.5, 1.5 times 10 power 6 over, not over, 41.5 times 10 power 6 times 2.0 times 10 power negative 3. Okay, I think the answer is like 82 or something like that. 82,000. Is it 82,000? Or 83,000? 83,000. Which is less than 85 kilonewtons. Okay, method number two, of course, is you can say max pressure allowed is equal to 85,000 over your area, and you will get 42.5 times 10 power 6 Pascal, which is more than what you are facing at that depth. Okay, different ways. You can choose which one. Of course, your explanation should align with your workings. Are we okay? Shall we? Can I? Did I go through this in class, part E? I didn't go through. Did I go through? I went through. Okay, basically this one, okay, there's two explanations. One is the easier one and one is the stupid one. Okay, the easy explanation, remember? Who's on the table? Was it easy? Okay. So the explanation is, with lower depth, there's lower temperature. Correct or not? Colder as you go further away from the surface. Lower temperature means what? Contract. Okay, volume decrease. Volume decrease, density increase. I will not bother you with another explanation. It's great.
Is it because there's more sharks and fish?
No, it's not sharks and fishes, but it's the impurities. It's the impurities and sediment that collects the chemical. Do you say that? More stuff? You say stuff?
No, I did not.
If you say more impurities and like salt, there's salts at the bottom and all that stuff. Okay, question 20. Describe how resistance of the thermistor changes with temperature. Okay, one go up, one go down. Okay, anything to suggest an inverse relationship. Initially, the thermistor is cold. Explain what can be observed for the lamp once you close your switch. I want to hear your answer.
It doesn't light up right because the resistance is very high and it causes less current.
Okay. So firstly, we say that when the switch is closed, okay, the lamp initially will not light up. You are correct. Okay, reason being resistance of thermistor is very high, hence current is very low. Current is very low. Okay, now, normally this question would be definitely be worth more than 2 marks in exam. Okay, because I need to talk about the following scenario, aka as time passes, okay, temperature will increase because your heating element starts to work. Agree or not? When temperature increases, what happens to the resistance of thermistor? Good. Okay, your resistance of your thermistor will decrease. Thermistor decreases. Hence, current increase. Current to lamp will increase. And of course, it will like that.
I said at first the lamp will be very thin.
Very. Okay, to be fair, we all don't know that it won't like that. That's fine.
You know the rating?
Rating. You all know the rating?
No.
Oh, yeah, that's right. That's right. Are we okay for part B?
But you never mentioned the heater.
Correct. But if I leave the switch on, there's going to be energy passing through your heating element.
Oh.
Okay.
Isn't there already last time?
What food? Hello, come back. What's going on? Yeah, as time passes, your heating element starts to operate, and then temperature increases throughout the entire cycle. What's going on? What the fuck is going on?
No. Ashan, make it.
Okay, good. Are we done?
No. Take it out.
Done. Okay. When the lamp first lights up, current flowing through is 20 milliamperes. Resistance of the lamp and heating element remain the same. Potential difference across the lamp. You all need help for this? I believe it is 1.3 and 0.2. Need help? Oh, okay. Let's see. So we have 1.5 that will be shared between these two guys. Yes. Okay, current flowing through this fella is 20 milliamperes. Harry, what's your voltage of the lamp? What's your potential difference through the lamp? Tell me.
Voltage. Yeah, correct.
What's the answer?
20 times 10 power to the 3 times 10.
Yeah. 0.
0.02. Not bad. It's 0.02. So 0.2.
Oh my gosh, I think I'm fucking dead. 0.2 volts. Okay? Then your 1.5 is shared between this guy and this guy, so this guy will get 1.3. That's all. Easy? Okay, good. Next. This fella, okay, I know what the next question asking, so I'm not going to go through that, but I will explain to you. 1.5 volts, 10 ohms. David, what is the current passing through this point? Okay, so this fella experienced 0.15. This point X you experience 0.02 amperes, so that means your ammeter is 0.17. Yes? Is that okay? Yes, you? Good. Alright, then you have some shit here. Did I explain this in class? Yes, right? Okay, I talked about why the name convection oven is very misleading. Okay, good. Question 21. Explain why when the current in coil A is switched on, millivoltmeter indicates an induced EMF for a short period of time and then decreases to 0 rapidly. Charlotte? Do you have the answer sheet? Jao? What you also going to do? What's you going to do? Henry? Oh, let's go.
When the current is switched on, the changing current induces a magnetic field which releases a EMF in coil B. Once the current in coil A stabilizes, the magnetic field becomes constant because it increases the EMF and the coil is shot to 0.
The current stabilizes. There. Okay, I would agree with you on the first part. Okay, which is that yes, once you turn on your switch over here, there is going to be a current flow through this coil. When there is a current flow through this coil A, this entire thing becomes an electromagnet. Correct? So that means you will generate a change in magnetic flux in coil B, and this change in magnetic flux induces an EMF. You are right. Okay, so up to that point, we are correct. So let's say, firstly, when current is switched on, okay, coil A becomes an electromagnet. Okay, now after it becomes an electromagnet, this produces a change in magnetic flux linkage in coil B, which induces an EMF in coil B. Full stop. This gives you your first mark. Very stingy question. Okay, your second mark comes from saying why does it reduce to 0 rapidly? So we will say that since the magnetic flux linkage is constant, okay, aka after you shoot up to that value, you stay at a constant value, correct or not? Okay, there will no longer be an induced EMF. There will no longer be an induced EMF after the increase. Okay, Faraday's law says that your EMF is only induced if there is a change in flux linkage. Are we okay? Jenny, okay? Can answer the next one?
You say it's a DC current.
Yeah?
No.
Yeah?
No.
What?
You say it's a direct current, not alternating.
No need. I mean, you can, but where would you see direct current? Coil A. Coil A or B? A could also, you're going to say that A is a direct current, so your magnetic flux linkage is constant. Sure. Go ahead. Draw an arrow on coil B to show the direction of the induced current in B when the switch is just open. Okay, so it's gonna, bear in mind guys, I draw A first. It's gonna go like this. So that. Jenny, can you tell me for coil A, who's north and who's south? Top or bottom?
What is north?
Was that a guess?
No.
What do you use?
This.
Jump. This one, Okay, good. So down here north, down here south. Then for coil B, top is south or bottom is south?
Bottom.
Ooh. No. The top is side. Okay? This is LL. What's LL? Lenz's law. Okay, which says that when there is a change in flux, your current is going to flow in a way such as I oppose this change in flux. Imagine I suddenly create a magnet right in front of you. You want to push the fucker away, right? Getting too close, right? Okay? So you'll push the south away by forming your own south here. That's why there's an induced EMF in the first place. Because we're trying to push him away. So look at how the four fingers are going. Okay, they're going this direction. So the answer is this one. Okay. Are we okay? Oliver, good. Kendrick? Trevor? Okay. Explain the direction shown in B part 1. Okay, essentially we are going to be quoting Lenz's law. So, how are we going to say it? We are going to say that when the increase in magnetic flux linkage, very sharp. Do you do the question?
It's because of Lenz's law.
But do you do it? Do you write anything there? When the increase in magnetic flux linkage occurs, okay, current in coil B. Okay, you don't have to explain the origin of your EMF again because you're going to double explain, there's no point. Okay, current in coil B will flow in a direction so as to oppose the change in flux. The change in flux. Hence, it will flow as shown. Okay? Now, you do not have to bring in right hand grip rule, so form south pole on top.
You say by Lenz's law.
Oh, I actually checked. We don't need to say by Lenz's law in my Faraday's law here.
That's good.
Yeah. So it's a little benefit for you guys. Why not? Because last time they took away the requirements because their priority is on understanding. Which I think is good for you guys. Are we okay with this? Get it? Yeah? Sure? Okay, next one for you. Okay, 2 coils of insulated wire. Okay, the lamp is operating and its current rating calculating minimum current drawn from a 16 volt supply. The answer for this one is 1.5, I believe. Are we okay? Anyone never get 1.5? Go. Ready? No. Why no? Okay, Harry, tell me. This is 24 watts.
So it's 2A.
What's the yeah, okay, 2A. Sure. What's the power that you output here? Power. What's the one thing that makes a transformer work?
Same power.
So that also 24 watts, right? What's the current? Fuck up.
Oh, 24 divided by 160.
Okay. Next. However, the current drawn from the supply is 1.7. Can you calculate input power now?
Yeah.
Can, right?
Why you
Okay.
draw from the supply?
Yeah. Yeah. This fellow is 1.7 amperes instead of 1.5. No issue.
Yes.
Good. Calculate electrical energy lost by the transformer. I can't remember the answer. 3.2. Who say 3.2? What is it? Oh, okay. 3.1. How do you get 3.2? If your method is correct, I'll trust the answer is correct.
I will see from answer sheet for the full unit. They took 27.2 minus 24.
5. Okay, this one's 27.2. 27.2 minus 24 watts. 24 is your left, 27.2 is input. So you lost 3.2 watts. Boring. State one reason why a transformer is not 100% efficient. Jerry? If you could guess. What's the main reason for inefficiency? What? No, not time. It's not 100% efficient because energy lost as. Why is it lagging? Hello? What's going on? Okay, I can't copy right now. Energy lost as heat would be your answer. I'm going to cancel this. Okay, now please take out mock paper number 3. What? Who's the smartest in the class? Obviously, it's you, lah. Why? It's you, You're so smart, bro. Yes. You only have break?
Yes.
When is the answer not yes from you?
I cannot.
Here, Sukiya downstairs. But the queue will be longer than the break I'm allocating.
Yeah, then how? When got anything
KFC,
fast.
KFC.
Fast. KFC is not that fast. So
It's okay, I will take snack.
Who's serving your KFC? Who's serving your KFC? No, who's serving your KFC? Who's serving your KFC? What's the main? Yeah, no, I say. I record it.
Shafi!
What? Shafi is serving your KFC, no lah. Maybe next time.
Well, I'll be the one who owns KFC, right?
Zero, no lah. Okay.
Wait,
Should
should I like what I was just I like fix it. I fix it like I fix it before, right?
No, but
Then I do special consideration. Then how like if I do a very well, I'll still get A1. But if I don't do that well, I'll still get A1.
no, you won't.
No, yeah, special consideration.
Special consideration doesn't mean you can never be automatically at A1.
No, as in like, cause I know I know I'll.
Okay, come, let's go through. Okay, before we continue, guys, let me just make an announcement. Okay, so for today's lesson, okay, we finish this one. 2 weeks from now, after I come back, okay, 12, 13, oh sorry, on the 12th of August, I told the Monday class already, everybody is going to be here. Okay, and the reason is because, well, I owe you guys a makeup now. Okay, so the Monday lesson, everyone here, we are going to do mock paper number 4 together. Okay? Okay, so the issue with that, right, is I wanted to do it on Monday, then Tuesday I go through the paper. Tuesday and Saturday I go through the paper. In other words, if you are part of the Tuesday class, you come on Monday, Tuesday. If you're part of the Saturday class, you come on Monday and Saturday.
But my mother at home.
Why?
What I think that's good.
I'll cannot make it on Monday.
Yeah, sure. You want give me anything else?
Can like need the paper and do at home.
It's
Actually, alternatively, right?
See Malaysian class.
I still got class.
She wants to me alone.
No, I said I was sleep.
Wait, let me think. Monday.
And we have any class and then we do at home. You just have to trust that Shafi will do it.
That just turned off the entire idea, right? Okay, I'll think of something. Okay, okay. That's
So
fine.
online please, not online please.
Huh? Online.
Not online lesson. Record.
When have I ever done an online lesson? Like
Record. You need
oh,
recording.
recording. Oh, you want recording? Okay.
No.
I know. I think you want recording. Chill. Okay. Say and explain how the pressure of the chair on the floor differs in the two positions. Kristen, how does pressure differ?
The base area of the chair in contact with the floor in figure 3.1 is larger than the base area of the chair in contact with the floor in figure 3.2. By F equals Q over A, the pressure of the chair on the floor in figure 3.1 is lower than the pressure of the chair on the floor in figure
Where F equals to P. But okay, good. Okay, so she did explain that yes. Okay, because area of chair in contact with floor is higher or greater in 3.1 than 3.2. Okay, then she brought in hence, since pressure equals to force over area, force per unit area. Okay, but what we might want to include also to eliminate all possibility of any minusing of marks is since the weight is constant. Okay, 3.1 having a higher area will exert a lower pressure. In other words, you claim, you make it very known that your F is constant, which means pressure is only determined by your area. Okay, lower pressure.
I think you say force instead of weight.
Yeah, that's right. Here, the chair and the student fall over if the chair is tilted backwards more than what is shown in figure 3.2. Why? Sherry, what do you think? He falls outside the line of action of the chair. Okay, we will include the word line of action, but it's not that you fall outside the line of action. The line of action is the thing that falls past your pivot. Yes. Okay, so you'll say that you'll fall over because line of action of the student's weight falls beyond the pivots, or you can say beyond the base of the two chair legs. There is something. Okay, hence. Okay, not just this, hence it will produce, or there will be a resultant moment that causes him to fall.
Do you see the center of gravity now falls outside the base of the chair?
center of gravity, line of action of your weight. This thing is actually your center of gravity. So if you exceed that, the center of gravity of the weight of the student and the chair go beyond the base of the two chair legs. That's okay. I just need you to tell me that now there is a perpendicular distance, so there is a moment, so it forms. Okay.
When you write the first part, then you write the resultant, how many marks?
You'll get 2. This one, the resultant moment part is 1 mark. Actually, sorry, it should be resultant anti-clockwise for the 1 mark. Make a list. Another, okay?
And that's the one.
Daryl?
If you never say the anti-clockwise moment is greater than the clockwise moment, then it's not a true
The issue with that, right, is there is actually no anti-clockwise moment. Now we just have, let's like this the edge, right? Now we just have, there is actually no clockwise, there is only anti-clockwise. So it wouldn't make a lot of sense to say anti-clockwise is more than clockwise.
So it's wrong.
I mean, I wouldn't give a mark. I don't think, I think like a more is really lenient. But
What do you mean there's no clockwise?
there's no clockwise because there's nothing past this point. It's your center of gravity shift this way. Apart from center of gravity, what else do you have for this? Hello? It's not like holding a cat or whatever, right? So there is only anti-clockwise moment. Anyone else? Okay, I'm okay to discuss. It is good that we discuss these kind of questions.
Because line of action.
Cool. Did you do this? Did you do this in Spartan? Last week? No.
Actually falls outside the center of gravity.
Line of action falls outside the center of gravity.
Out of the center of gravity.
Your line of action is the center of gravity. It's line of, you either use line of action go beyond the pivot or center of gravity go beyond the pivot. Those two things are the same. Because the center of gravity is where your line of action of the weight is.
I thought line of action is the thing where it acts on and then the center of gravity.
Yeah, correct. But like if I visualize this fella, right? Okay, you lie down. Your center of gravity, this is your weight. This is the line of action. This is your center of gravity. So you cannot have your center of gravity cannot be next to or whatever. Like they are the same point. Stop talking and I won't have to keep going. Nothing. He just said that your center of gravity cannot go beyond the line of action of the weight. Because it is literally equal to the line of action of the weight. Center of gravity is where your weight acts on. Moment of the plank, this one you should get 299. Easy? No? Why? Moment of the plank. 23 kilograms, so 230 newtons, right? 230 newtons acting where? From your right hand support. How far away? What? No, how far away? Not this one. Moment of the plank is the plank. The plank's weight, not the fella's weight. The fella's weight. It's your plank's weight of 230 acting 1.3 meters away from the support. That's all. So moment, force times distance. 230 times 1.3. Are we okay? Yeah. Explain why the plank rotates, okay, as he moves further to the right. Here is our answer. Okay. In order to rotate, okay, this is where we have both clockwise and anti-clockwise. There we are comfortable. Okay. If I want to rotate, guys, means my CW has to be greater than my ACW. Agree or not? Okay, I cannot rotate anti-clockwise now, the other support is not there. Okay, so we are going to say that. Okay, the anti-clockwise moment Stupid. Sorry, let me start from clockwise moment. Clockwise moment by painter's weight. By painter's weight is greater than the anti-clockwise moment by plank about the right hand support. Okay, if you want, I will leave my answer like this, but if you insecure, you want to add in some more thing and you have enough time, say that, hence, there is a resultant moment and you rotate. There is a resultant moment and the plank rotates. This is fine as well. Question? You guys get this? Okay, don't have to write to be correct, right? Use your method. Okay. Painter is a mass of 80 kilograms. Calculate distance x from the right hand support you'll be standing at. The answer for this one is 0.374. Just lift off means what? Means at that exact point, the fella just lift off your left hand support, correct? So that means this whole side is gone already. Useless already. Agree? Okay, but he just lift off now. So at the point where he's just lifting off, his moment and the moment by the plank is the same. Just lift off. Agree? Just. So he just lifted off your left support. He's not touching it anymore. But at that point, when you just lift off, yes, correct. So your clockwise moment by his weight and your anti-clockwise moment by the plank's weight is the same. Just now you calculated 299, right? At least. So now we have 299 equals to 800 times x. Calculate x. Very okay.
299.
Shafiq? Good. Good. Okay, next. Sorry, this one should be 10 power 5 kilograms. Now, for this one, okay, I know you guys can draw. Okay, very good. Okay, chances are you guys probably got the 15. Y'all like maybe increase until here or something, then go straight. Okay, fair enough. But okay, if you just randomly increase to a certain value and then went straight, you will probably not get the mark. Okay, why? Because your coordinate here needs to be a certain y value. I cannot just stop at 50. Okay, for those of you that got it, okay, your point should be 120. 120 crisscross with 50. If you manage to get this, means you quite high already. Okay? Anybody manage to get? Got? Very good. Okay? How do I know that it's 120 and at 15 seconds? Okay, let's go through. Time t equals 0, your train begins to accelerate non-uniformly, reaches a speed of 20 meters per second at 50 seconds. Correct? Okay, at this point, you are going to continue at a speed of 20 for 10 seconds. Then you start to slow down. So, when do you start to slow down? At this point, okay, Olivia, how far away am I from my start point? 320 meters. Okay, so this is 320 meters. Okay, and 320 meters is after I have continued at a speed of 20 meters per second for 10 seconds. During this period, you travel 200 meters. In other words, right guys, from 15th second to 25th second, you traveled 200 meters. Right? So then I know where I ended. Because the difference between is 200 plus. Okay, so we're going to draw a straight line. Here. Okay, I don't have a ruler, so I'm using the correction given to me by the app. Okay, and then from here, I accelerate. So I just have a nice little curve like this. Any questions? You get 120 as well? You know how to get 120?
Why does it have to be increasing acceleration?
It's not increasing acceleration, it's just acceleration.
So it's like straight line.
No. This is a distance time graph.
Yeah.
So your gradient is velocity.
Oh.
So if it's accelerating, all I need to show is that my velocity is increasing, aka getting steeper. I don't know by how much is it getting steeper. Okay, calculate kinetic energy. This one is, can't remember. Let's just do it. Half times 1.8 times 10 power 5, velocity of 20 squared. 3.6 times 10 power 7. Thank you.
20 squared.
Half mv squared. Are we okay? Shafiq? While the train decelerates to rest, it does work against the resistive forces and Ke decreases. Define work done, force time, okay, let's do it properly, okay? The work done is product of a force and the distance moved in the direction of that force. Okay? If you just say product of force times distance, you will get 0. I need this part. Okay? Okay, okay. Determine distance moved while it's decelerating from 320 up to, I believe it's 560 over here. So the answer for this one is 240 meters. Anybody cannot get 240 meters? Why? Deceleration is from 320 to your maximum distance, 560. You will do again, use your ruler and draw a line. Wait. Okay. Now, resultant force acting, okay, you have force times distance gives you energy. The energy that you possess at the very beginning is the Ke, agree or not? Okay, so down here you have your 3.6 times 10 power 7. Force is what you want to find out. What's the distance, Shafiq?
140.
Agree. Then you calculate force. One 150,000 or 1.5 times 10 power 5 newtons. Are we okay with this? There is another way to do this, of course, okay, which if you want to, it might be easier for you, where we use F equals to mass times acceleration. Resultant force, huh? Correct. Okay, meaning what's your mass?
Resultant force, why is it? Because it decelerate, right? And the resultant force is really accelerating.
Okay, good point for that. Oh, fuck. 1.8 times 10 power 5, then what's your acceleration? calculate it. Why? What's your initial speed and what's your final speed? Final speed is? Final speed is what? You decelerate or stop, right? What's your final speed? Yes. How long do you take to decelerate? Look, properly. It is not 25. Read the question. Okay, and you can also use this to calculate answer. Now, Harry, in answer to your question, okay, your resultant force acting on the train, we have never designated a positive or a negative in this scenario. So I don't have to treat this way as well. Force is a vector, yes. But resultant force, when I'm calculating, I can use either this way as positive or this way. They never say. Correct? Okay, so by resultant force, yes, this one is acting against your train, but that can also be a positive value. Yeah? Getting? Okay? Okay, anybody else? Any problem?
We want 20 minus 0.
Change in speed over change in time. Is acceleration.
Change in speed.
You started from 20, you decelerate all the way to 0 over a period of 24 seconds.
Then you lost 24.
Over a period of 24 seconds.
Oh.
Yeah. Okay, good. Good. Okay, question 18. Suggest why the times are different. Okay, this question is a little bit interesting. Okay, we remember that the hotter something is, the faster you lose heat. Correct? Or to be more accurate, the bigger the temperature difference between two things, the faster heat is transferred. Do you remember this?
Yeah.
Okay, some yes, some no. Okay, that's fine. So let me explain. Because this fella at the point is still considered hot. Okay, 20 degrees. When you compare it to the freezer, of course, it's very low, very high temperature. Correct? So there is a big difference in temperature during that period, aka he will lose heat very quickly. Comparatively, over here, he loses heat a lot more slowly because now he's a lot closer to the temperature of the freezer, whatever it is, whatever, how low. Make sense? Okay, so when we are explaining, we will say that, okay, why is the time different? In liquid state, actually, okay. In liquid state, okay, from 20 degrees to 10, okay, there is a bigger temperature difference between the oil and the freezer. Hence, it loses heat more quickly. Finish. 2 months. Alternatively, of course, you can say that it is at a higher temperature, so it will lose heat more quickly. That's fine as well. Explain in terms of molecules why the temperature does not change between 3600 and 10800. Sarah?
From time 3600 seconds and T081080 seconds. All the change were using point over space between particles to
That? Oh, that's it. Is that what you wrote? Okay. So, firstly, we will say that yes, indeed, okay, between 3600 seconds and 10800 seconds, okay, energy is being lost to surroundings as the particles are being drawn closer together. Drawn or attracted closer together. Okay. However, marks wise, we will also include this energy is being lost in the form of potential energy. Hence, since kinetic energy is constant, since kinetic energy is constant, temperature doesn't change. Remember that state change is based on potential energy, temperature change is based on kinetic energy. Sorry, I shouldn't say particles, I should say molecules. Let me just change that word. Are we okay? Say it up. KE is related to temperature. Okay, PE is related to the distance between your particles. If I have a bigger distance, I have a lot of KE. Smaller distance, less KE. Yeah, less PE. Potential energy is based on the space between our particles. So if we are very far away, means each of us has very high potential energy. That's why I don't have to go close to it and push away. Right? But as we lose that, then we'll get closer and closer and closer and closer. Which is not satisfying.
So the solid have low potential energy.
Correct.
Key is what?
KE is related to temperature. PE is related to intermolecular distance. Okay. Okay, 45 grams of oil. So your energy transferred 5.7 times 10 power 4 times 0.045. 45, 10 power 93. 2565 joules. Sorry. AKA 2570 joules. Average rate, average heat is transferred. Okay, you have 2565 divided by the time 10800 minus 3600, 7200. Your answer is 0.35625 or 0.356 joules per unit time. Okay so far? Okay. Do you do this question? You do. Oh wait, fuck, what I'm talking about. Yes, correct. The graph in figure 5.1 is steeper before than it is after. This is where we bring in specific heat capacity. We will say, okay, remember guys, your Q equals to MC delta T. Okay, M is constant. This one is constant. Don't care about it.
What's the question?
What?
What's the question?
Oh, explain why is the question. Okay, M is constant. Q per unit time is also constant. True or not? Okay, our focus is on why is this value different. Okay, so if your Q over T is constant and your M is constant, the only thing affecting this guy is your specific heat capacity. So we will say that, okay, heat capacity. Okay, wait, let me think. Shafiq, if you have a higher specific heat capacity, will you have a steeper or a gentler gradient? If you have a higher specific capacity? Will it have a steeper or a gentler grade? Good. Okay, so why is it steeper before? We will say that specific capacity is cap
The horizontal section.
of liquid oil is lower than the specific capacity than that of solid oil. Hence, rate of change of temperature is greater. Finish. Someone is right. Are we okay? And what is the horizontal section? Harry, horizontal section is your freezing process.
Can you explain why it becomes gentle?
Then, because your energy is being lost at a constant rate, right? Because you are using a cooler, ma. So over at this point, okay, it's steeper because your change in temperature is faster because your C value is very small. If we use Q over T, power equals to M times C times change in temperature over time. Okay, the bigger this is, the smaller this will be. So as a solid, because this is very gentle, means your specific capacity value for solid oil is very high. Yeah. Any questions? Oliver, okay, no? You just got it today. Kenny, you also? Okay. Sure. Agreed. But because they are asking for gentle versus steep, right? That means we are focused on gradient. So I have to bring in per unit time, dy dx. For those of you who want involved. Okay? Alright, question 19. Question 19, very interesting, very fun. Determine focal length of the lens. Okay, now, I know you guys have slightly different drawings, okay? Not slightly different, I mean you guys have different drawings from mine. Okay, aka this one is not actually 1 cm. The answer put 6 cm. But I think for you guys it should be like 5.6, right? Is it about 5.6? Or do you all get exactly 6 cm? 5.8. Okay. Go. That one is like a printing thing, okay? Because when the school did it, they are calculating based on their measurements. Alright? So I will accept any value that's reasonable, okay, based on your drawing. But how do we draw divergent lens? Okay, this one is interesting. Okay, I will draw a straight line here. Now, for convergent lens, normally, at this point you are going to cut through your focal point. Agree or not? That's your normal scenario. However, for this case, we are still going to cut through focal point. But we are going to cut through on the other side. Okay, because you know divergent means after your ray passes through, you go like that, ma. Correct. Okay, but I cannot just go in some random direction. So I will follow along and cut through my focal point on the left side. Okay, but we are not done. We need to extend this line past like this.
What is diverging velocity?
Your rays after pass through go out like that.
Converging lens.
Yeah. Correct.
How will the diverging lens look in real life?
How would a diverging lens look in real life? Zoom in. Zoom out. Zoom in, not zoom out. Okay? What's the next ray that we're going to draw? Obviously, is the one that is very familiar to everybody. Pass through your optical center. And as with our converging ray, the intersection is our image. Okay? No matter whether we follow the school's printing or not, okay, your height value, you should get about 1.6 to 1.8, I think. Is it what that? Magnification 0.6 is your answer. Okay, magnification is what? Height of image over height of object. We're not done yet, don't forget. Okay? Can somebody tell me if my image falls on the left side of my lens, what property does it have? What's unreal? If you're not real, you are. Fuck you lah, not fake lah. Virtual is the term we are going to use. This fella is virtual, not fake, not unreal, not whatever. Okay? Given that he's virtual, that means the rays that form him also don't exist, isn't it? Okay, so what we're gonna do, take your eraser. If you are bobo enough to use a fucking pen to do it, get your correction tape ready. Okay, we are going to shade this guy here. And that's it. It's just it. Because this red one definitely exists. Fastest straight off your center. Magnification is height of image over your height of object.
0.6.
So 0.6 is the value. So no matter what, right, you measure this one versus you measure this one, you take the ratio.
0.6.
You'll get 0.6. Question? Noah? State two ways in which a virtual image differs from a real image. Kendrick? You can give me one and Charlotte will give me the other one. Okay, virtual image cannot be projected onto a screen. Good. Cannot be projected onto a screen. Charlotte, let's go. Okay, you can just draw reference to your normal conversion lens and realize that every time you have a real object here, what's another property that you'll share? Is what? If I have a arrow like that, you'll point this way. Is inverted. Can reach that.
Is it inverted?
But if I have virtual, he'll be here. And then he will be what? He'll be upright lah. You'll form this one. Right. If you are virtual, you are upright. If you are real, you will be inverted. You cannot be real and upright. Physically impossible. Okay? So, another difference of course is that your virtual image is upright, while the real image is inverted. Question? Levin, okay now? Alright, good. Let's move on. A alternating current. Sketch a graph to show how the EMF between X and Y varies between two complete revolutions. Okay, the student rotates as shown above. As shown above, AKA, this is how I am starting. Your graph will look like this. Fuck. When have you ever gotten negative cosine? Wait. Then you get negative cosine. Okay, fair enough. If you draw negative cosine, you'll be awarded a as well. Because we never say whether it's maximum positive or maximum negative. So what was it? You choose.
So this is a sign.
The blue is the sign. Really? Blue is sign. Mark and label a point P for the EMF when the coil is horizontal. Any of your peaks, you will get your answer. This can be P, this can be P, this can also be P, this is also P, this is also P. Any of them, either press or cross.
What P? What you put P? Oh.
Shafi, okay? Why are you so stressed? Yeah. Say two ways in which the EMF changes if I turn the handle more quickly. General? Huh? Higher EMF, we will say higher amplitude is the change. What else apart from higher amplitude or higher EMF? No. Mabel? David? What about frequency? Oh, sorry, okay. I was expecting you to say your frequency will increase. Okay, alternatively, you can say the period will
Decrease.
wait, what?
Time
Am
taken for-
I retarded?
No.
Oh yeah, period decreases, correct.
Frequency decreases.
Yeah, nice.
Oh.
Okay, next. Terminals X and Y connected to the primary coil. Stay and explain what happens in the transformer as he turns the handle. Rachel? No? Sure?
As the student turns the handle of the AC generator, an alternating EMF is produced which travels through the primary coil of the transformer. Since there's now an alternating EMF and current, there's a magnetic field form which causes the transformer to become an electromagnet. That is all.
Then you stop.
Yeah, I know.
Okay. So, we will say that yes, indeed, okay, an alternating EMF is induced, alternating EMF is produced, okay, in the primary coil of the AC generator from X and Y. Okay, then with my alternating EMF, we also have to mention the formation of a changing magnetic field. Hence, a changing magnetic field is produced in the transformer, which produces a changing magnetic flux linkage in the secondary coil. Okay, your transformer is not just the iron core. Your transformer is the iron core and the two coils. So talk about the coils as well. Okay, we show you the changing magnetic flux linkage in the secondary coil, and then of course our favorite Faraday's law. Hence, an alternating EMF is induced in the secondary coil. What? Is it China? Explain why the power losses in transmission cables are lower when electrical energy is transmitted at higher voltages. Okay? Let's go, last one. We always talk about it, right? Like what's the purpose of your transformer? Okay, very good. Why? How does it reduce power loss? Not resistance. Yes. What was your current? Yes, it will decrease. What? Why keep talking about resistance? No? Okay, your power loss. What's the power loss formula? I square R. Your R does not change. This one is the one that you decrease. Okay, so firstly, we will say that power in the cables is constant. We will say that first. Hence, at higher voltages, okay, at higher voltages, keywords here, current through cables is lower. Therefore, as power loss equals to I square R, okay, less power is lost in transmission. Finish. Just nice. Oh, oops. Are we okay? Okay, so that's it for today's lesson. Okay. Again, I remind you all, next week, no class. This Saturday, for my Saturday kids, no class. Okay. I will see you guys next on either Monday or Tuesday. I will confirm that together with you guys. Okay, so 12 or 13 of August will be our mock paper number 4. Go and do your revision. Okay, I know it's release period, so you guys should be doing your revision anyway. Okay, not like fucking around anymore. Okay, release is just right around the corner, literally. Okay, for many of you, I think practical is like next week, right? Next week. Starting. Next. Week after that. Practical. This Saturday don't have, the following Saturday. That's why you have 2 weeks. So Saturday is 2 weeks. I don't send people the day before. Later today. When we do an event, 2 weeks gone and not forget. Yeah. What do I do? Go.